A survey finds that women's height are normally distributed with mean of 63.4 inches and a standard deviation of 2.4 inches. A branch of military requires women's height to be between 58 and 80 inches. Find the percentage of women meeting the height requirement. And then we want to know, are many women being denied the opportunity to join this military branch because they're too short or too tall? So this problem is the same as finding the area under the standard normal curve between two values corresponding to the minimum and maximum. So from there, we can use StatCrunch. Since this is based on a normal distribution, I can go on Stat Calculator, select normal, and since we're finding the area between two values, I'm going to choose between. So enter the mean. In this case, mean of the distribution is 63.4, and the standard deviation is 2.4. And the height requirements are between 58 and 80 inches. So between 58 and 80 inches. And then once we click compute, we can see the area between 58 and 80 inches. So the area shaded converted to a percent and 2 decimal places is going to be 98.78. So about 98.78% meet the height requirement. So that means most of them meet the height requirement. So are many women being denied because they're too short or too tall? No, because only a small percentage are not allowed to join. Now, part B, we want to find a new height requirement. So this branch of military changes the height requirements so that all women are eligible except the shortest 1% and the tallest 2%. So we want to know what are the new height requirements. So to find the shortest 1%, we want to find the height with 1% of the total area under the curve to its left. So to do that, we're going to go on standard calculator, and to find the area to the left, we're going to use a less than equal to, and area to the left is 1%. So this will give us the height with 1% of the total area under the curve to its left. This is the new height, which is 57.8. And for the tallest 2%, we want to find the height with 2% of the total area under the curve to its right. So in order to do that, to figure out the tallest 2%, we're going to use a grader. And into the area, it's 2%. So 68.3.